What a time we are living in. After rattling the AI world with their DeepSeek reasoning model, DeepSeek has now started releasing the underlying technologies, the underlying source code, and their architectural semantics for the community. In their first release, they have shared Flash MLA. This is Fahad Mirza and I welcome you to the channel. In this video, I am going to explain this Flash MLA in as simple words as possible while keeping its spirit intact. Not only that, I am also going to explain its use cases and I will also show you how you can also use it in your own project if you are looking to host DeepSeek R1 model in your own data center or in your cloud or in your own setup. So let's get started and try to understand what exactly is this Flash MLA. And by the way, I'm not expecting you to be a machine learning engineer or AI guru. So let's try to understand it in as simple words as possible. So what exactly is this Flash MLA? Flash MLA is a software that is optimized for NVIDIA's Hopper GPUs to enhance AI tasks that involve processing varying length of text-based inputs. NVIDIA has a lot of GPU families. Hopper is one of them, and it seems that DeepSeek has trained their DeepSeek R1 model on Hopper GPUs. So if you're looking to implement it in your own data center, you should be using Hopper GPUs, and then on top of that you need to install Flash MLA, which I will be also sharing you how to do that. This Flash MLA specifically targets improvements in multi-latent attention. What it means is that where the model focuses on important parts of the input. It also uses flash attention to reduce memory usage and speeds up processing compared to traditional method. Now let's dive a bit more into it. And before that, let me also thank our sponsors of the video who are Camel AI. Camel AI is an open source community focused on building multi-agent infrastructures for finding the scaling laws of agents with applications in data generation, task automation, and world simulation. And I will drop the link to their website in video's description. Okay, let's get a bit more into this Flash MLA. So first and foremost, as I said, it uses NVIDIA Hopper GPU's power that achieves high memory bandwidth around 3000 GB per second and compute performance is 580 teraflops. This means it can handle a lot of data very quickly that surpasses non-optimized models on these GPUs. One of the key things is the support for variable length sequences. This Flash MLA processes different text lengths efficiently. That's crucial for real-world applications like language translation and chatbots. This is an improvement over models handling fixed length sequences. Another cool thing about it that it uses paged key value cache. This is where Flash MLA breaks data into manageable blocks, reducing processing latency. This is more efficient compared to naive memory management methods that can bottleneck large-scale model performance. Flash MLA utilizes BF16 precision, decreasing memory usage and speeding up computations when compared to higher precision formats like FP32. It balances computational speed with adequate accuracy. It also leverages optimized memory use. Flash MLA can manage models larger than what typical GPU DRAM can hold. That allows significant efficiency improvements over conventional implementations. It is open source, you can use the code today, you can even modify it and use it for your own purposes. Also, just think about it. Flash MLA is already in production. That really underscores its reliability, and DeepSeek has tested it for their own model. So we really don't have to do a lot of rigorous testing. It is out of the lab. It is built on successful projects like Flash Attention. That really makes it quite efficient in AI inference, and by optimizing performance on Hopper GPUs, it really gives us a clear direction as where should be going. So for me, I think Flash MLA improves computational efficiency and memory management on NVIDIA Hopper GPUs, and it replaces less optimized execution models. Now let me show you how you can use it. So first up, just git clone the repo, and I will share the link in video's description. Once you have cloned it, just run this command and make sure you are using NVIDIA's Hopper GPUs like H100 and a few other variants. And then this is how you use it in the code. Now the code looks a bit scary, but let me tell you what exactly this is doing. So this code is showing how to configure and execute the Flash MLA kernel for each layer of a model, and it utilizes advanced CUDA operations and optimizes sequence processing using parallelism and GPU resource effectively. So I'm not going to go into each parameter detailed here because I'm also looking to create another video where I will be installing it, and I will be showing you how exactly it looks once you install it on Hopper GPU. So I'm just waiting for my Hopper GPU. As soon as I get my hands on it, I'm going to create another video. So bear with me. I will be making another one, and if you are looking to install in your own data center, you can still follow just these two lines to get it installed, and then rest is very simple code if you're a CUDA engineer, of course. So that's it. I hope that you enjoyed it. Let me know what do you think about this Flash MLA and generosity of DeepSeek to share this knowledge with us. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.